everyone, this is Mrs. Snook with section 1.4, Measuring Angles. And in today's lesson, we're going to find and compare the measures of angles. We're also going to name angles. First up, what is an angle? So an angle is formed when you have two rays and they meet at the same end point. So right here, here's your rays. There's the end point. That point there is called the vertex. And then inside the two rays is the interior, and then outside of that is the exterior. Now we name an angle in several ways. We can name it with 3 letters. We can name it with a number if that's given. And sometimes we can name it just by the vertex. It's going to depend on the situation. So take a look at these angles here. I can give 2 other names for angle KML, and I'm going to go ahead and highlight KML so we can see that. This right there, that's angle KML. I can name it by the K, the vertex M, and then the other point, so KML. I can also go in the other order. I can call it angle LMK. As long as your vertex is in the middle, you're fine. Also, because it's been given a number 2 in the diagram, I can call it angle 2. Now the next thing is, would it be correct to name any of the angles in this figure just angle M? And the answer is no, because there's actually 3 angles in the picture. And if I say angle M, I'm saying the vertex is at M, but there's 3 angles with a vertex at M, so I don't know which one. So for that reason, no, you cannot get away with just saying angle M. All right, next is we're going to use a protractor and we're going to classify angles. We can classify them as acute, right, obtuse, or straight. Now acute means the angle measures less than 90 degrees. Right means it equals 90 degrees. Obtuse is going to be greater than 90 but less than 180. So let's see, I'm going to say 90 less than your angle, less than 180. And then straight, that's where it equals 180. So that's how I'm going to classify these angles. First one I have is angle HKM. Let's highlight the angle so we know what we're talking about. Starts at H, goes through K, and then over to M. So that's the angle I'm looking at. And when I read my protractor, I'm going to zoom in so we can see this. It looks like it's going between 140 and 150 degrees. I'm just going to eyeball it. That looks like it's about 147. So I'm going to say 147 degrees. And this one is obtuse. Now let's look at angle HKN. So starts at H, goes through K, and goes all the way to N. That one's a straight angle. It's a full 180 degrees. And it looks like a line. So if you see a line and I'm asking you what the angle measure is, 180 degrees. MKN. So now we'll start at M. Start at M. We'll go through K and go to N. Now look at this one. Let's zoom in. So do you see how there's 2 scales on our protractor? I'm going to use the one that starts at 0, and it looks like it's going past 30, not quite all the way to 40. Again, just kind of estimate it, eyeball it. And to me, that's looking like about 37 degrees. So I'm going to put down 37 degrees. And that one's acute because it's less than 90. LKM. Let's find LKM. Starts at L, goes through K, and goes down. Now look at that. Neither of those rays are lining up with 0. So what I'm going to do is I'm going to get the measure of each part of M and L looking at the protractor. Then I have to do a subtraction. So M, let's call that 145. And then L, that looks like about 35. So now I'm going to do a subtraction. I'm going to do 145 minus 35. And when I do that, I get 110. And this is obtuse. All right, last one, HKN. At this time, pause the video and then try to do the measurement yourself, and then come back and compare with what I do. So pause your video now. So HKJ is 90 degrees. See, it goes from 0 to 90. So let's go ahead and put that in. Did you get 90 degrees? And this is a right angle. All right, next up, we have the angle addition postulate. So just like in the last section, section 1.3, when we could add segments together, we can also add angles together. So if I want the angle measure of this big angle, AOC, all I got to do is add AOB and BOC. So right there, just add AOB and BOC, and that gives you the measure of the big outside angle. So let's use that. So angle DEF is a straight angle, and straight means 180 degrees is its measure. What are the measures of DEC and CEF? I should point out that when you see that little m there, that means measure. Oftentimes we'll write it that way. Sometimes we'll just say angle DEC. And if you see that in an equation, that means the measure of that angle. So what I'm going to do is I'm going to look at my diagram here. And just like I did with segments, I can add these angles together. So I can say angle. I'm looking for measures of DEC and CEF. So I'm going to say angle DEF. That's the big outside angle. That's going to be the angle DEC plus angle CEF. So you see how I didn't write the little m's there, but I know I'm talking about measures because I put them in equations. Let's fill in what I know. I know DEF is 180 degrees because it is a straight angle. I've been told DEC is 11x minus 12. So that's DEC. And CEF is 2x plus 10. Okay, so now I have an equation. I have only one variable in there, and that's x. So I can solve this equation. Let's combine like terms. 11x plus 2x is 13x. And then we have a minus 12 plus the 10. That's a minus 2. So at this point, all I'm doing is algebra. Add 2 to both sides. 182 equals 13x. And then divide both sides by 13. Grab your handy dandy calculator. We're going to do 182 divided by 13. I get 14. So now I've got x. I'm just going to go back and plug in. So angle DEC, I know is 11x minus 12. So 11 times 14 minus 12, I get 142. And you now have your choice. You can plug in x to 2x plus 10, or you can subtract 180. So angle CEF, I'm going to do the subtraction, is 180, because that's my whole big angle, DEF, and I'm going to subtract away angle DEC, which is 142. And when I do that, angle CEF equals 38. So there's my answers, 42 and 38. Now, we aren't given a picture in this example, example 4, we're just given words. We're told T is in the interior of angle PQR. And then we're told find angle PQR if angle PQR is 10x minus 7, RQT is 5x, and PQT is 4x plus 6. Draw a picture. That's going to be your lifeline on a problem like this. Take the words and draw a picture. So the first thing I have is T is in the interior of angle PQR. So I'm going to draw angle PQR. I'm going to draw it any way I want. I'm going to draw it like this. Here's P, Q is the vertex, and here's R. Okay? Now it says T is in the interior. So somewhere inside the angle, I'm going to put T. And then it says find the measure of PQR if PQR is 10x minus 7, RQT is 5x. So now I'm going to put a ray in here going from Q through T. Angle RQT is right here, and I'm told that that is 5x. And then I'm told PQT is 4x plus 6. And the whole angle is 10x minus 7. So I'm going to set up my equation. I'm going to say angle PQR. It just erased a bunch of stuff on me. PQR is going to equal angle RQT plus angle PQT. Now plug in the expressions that I have. 10x minus 7 equals 5x plus 4x plus 6. That's the geometry. The geometry is done. I've written my equation. Now all I'm doing is algebra to solve my equation. So I have a 10x minus 7 equals, let's combine like terms, 5x plus 4x is 9x, and I have a plus 6. I'm going to subtract 9x from both sides, and that gives me x minus 7 equals 6. Add 7 to both sides, x equals 13. I have x. Now what I need to know is the measure of angle PQR. So I'm just going to plug in my x to PQR. I know angle PQR equals 10x minus 7. So plug that 13 in. 10 times 13 minus 7. Grab your calculator if you have to. Otherwise, 10 times 13 is 130, minus 7, 123. Your units are degrees. That little circle up there means degrees. So that's your answer. All right, we've got another one. Now take a look at this diagram. I have a diagram. I have some markings in that diagram. I have right here, I have an arc with a tick, and I have another arc with a tick. If they're marked the same, they are the same. So that means angle SOP is congruent to angle POT. Angle SOP congruent to angle P. Okay, they wrote TOP there, so I'm going to write it as TOP. Angle TOP. If they're congruent, their measures are the same. So let's fill in what I know. Angle TOP is 3x minus 1. Now this angle all the way through TOR is 8x plus 19. I need to find angle SOP. Well, I know it's congruent. So this is also 3x minus 1. This angle in here, SOR, I'm told is 57. So now I've got 3 angles. I can add 3 angles together to get my big angle. That's fine. So here I go. Angle TOR is going to equal angle, let's do ROS, plus angle SOP plus angle TOP. That's my angle addition postulate. I'm allowed to add my angles together. Now we're going to substitute in what we know. We're going to put in the expressions. So TOR is 8x plus 19. ROS is 57. SOP is 3x minus 1. TOP is another 3x minus 1. Okay, geometry is finished. Now we're just doing algebra. I'm going to combine like terms. So I have 8x plus 19. I have a 3x plus a 3x, so I have a 6x. And then 57 minus 1 is 55. All right, so now let's isolate x and we'll just solve. So let's subtract 6x from both sides. That gives me 2x plus 19 equals 55. Subtract 19 from both sides. 2x equals 36. X equals 18. So now the measure of angle SOP, that's 3x minus 1. Three times 18 minus 1. Get your calculator. 3 times 18 minus 1. I got 53. And don't forget your units. It's 53 degrees. All right, that's it for today's video. Thank you for watching and have a fantastic day.